Guys, how are you? Today I'm back here with a question from the November 2022 exam. And this is a question about centripetal force and rod and all that. So let's get started. A mass is attached to one end of a rod and made to rotate with constant speed in a vertical circle. Okay, so what we know about circular motion is we have the velocity component that's always tangent to the circle, and then we have the centripetal force that is always pointing towards the circle, and this makes sure that we are actually staying in a line. So the mass is actually staying in a line and not falling off. We are rotating clockwise. Okay. The scale diagram shows the weight V of the mass at an instant when the rod is horizontal, just like this. Okay. Draw on the scale diagram an arrow to represent the force exerted on the mass by the rod. Okay. So the forces that are actually being active on the mass are first, of course, its weight pulling downwards. This is the result of the gravitational acceleration. And then the next thing that's being active on the mass is the force exerted by the rod. So the force exerted by the rod should be in such a way that when all of the forces are on our mass or drawn on our mass, the net force should be equal to the centripetal force so that the mass actually stays in the circle when it's rotating. So in order to have something like this, we have to first have a component that balances a vertical component that balances our weight out. And then the second thing that we should have, of course, is our centripetal force here. So our centripetal force is always towards the center, and it makes sure that the mass is not, as I've said, falling off, and that it's rotating in a circle. So when we draw the resultant vector from these two components, we get something like this. That has a vertical component equal to the weight, and then a horizontal component that's pointing towards the left. Its length doesn't actually matter. Okay, so we have to draw this here. As I've said, two squares to the right, to the upward direction because it has to balance out weight. And then whatever you decide to, let's do this. And okay. So our vector here is the force exerted on the mass by the rod. And then, as I've said, the two forces acting on our mass are always the force by the rod, force exerted on the mass by the rod, and then the weight that's the result of the gravitational acceleration on our mass. And then all of these forces combined, tension, gravitational acceleration, and all of that, always should equal to the net force, that is the centripetal force, so that the mass is staying in the circle, because we always have to have the centripetal force. Explain why the magnitude of the force exerted on the mass by the rod is not constant. So the first thing that we'll write here is net force and let's say centripetal force. So the magnitude of net force and centripetal force is always constant, right? Let's say magnitude of the net force and centripetal force is always constant, but what changes, because the force exerted on the mass by the rod is the vector difference of centripetal force and then the weight, what changes is the direction. The direction of centripetal force always changes, and as I've said, because it's a vector difference, when its direction changes, it's ultimately not constant. And as I've said here, let's write it here too. Force by the rod is a vector difference of centripetal force and weight. So this is why the force exerted on the mass by the rod is not constant. Thank you so much for listening, guys. I'll continue with other questions in the future.